So in this question, we're told that a scientist is studying the growth of a bacteria colony. The population of bacteria at any time t in hours is given by the following function, and then we're asked how many hours does it take for there to be 5,000 bacteria. And so this is an interesting example of a function that you might see kind of in a more applied science. So we're using maths to understand something like growth and its exponential growth. So we're going to be dealing with that here. And so our first step is going to be to set this equal to 5,000. And basically what we're going to do then is just kind of reverse engineer this equation to then isolate t. So we're going to start doing that now. Our first step is going to be to divide across by 500, because you see there's a 500 here on the left, and so we have a 5,000 on the right, and we can just divide across by 500 first. And so 5,000 divided by 500 is going to give us a value of 10 on the right. And so this should be ringing alarm bells in your head that this is going to be a log. So what I always do for logs, it's kind of a handy trick, is just take the natural log of both sides. So we're going to take ln of e to the 0.3 t on the left, and then we're going to have ln of 10 on the right. And then just using the rules of logs we have in our log tables, we can take our power down in front, so we can use that to essentially multiply the log, and then the ln of v we're going to simplify in a second, and we're going to leave the ln of 10 as is. And so we know the ln, or the natural log of v, or kind of, if you think about it, what power you have to raise e as to get a base of e, it's going to be just 1. So therefore we know that 0.3t is equal to the natural log of 10, and then our last step is just going to be to divide across by 0.3, and then we're just going to plug that value into our calculator, and the value we're going to get out is going to be 7.675. So that's going to be our value of t, or in other words, it takes about 7.5 hours for there to be 5,000 bacteria from the initial 500.